From this video, we start shear and bond in our RCC member. In my last few video, I am trying to cover the beam design in WSM method. So in case you miss this video, you go to RCC playlist section and find the last video. Hello friend, I am Sammadeep back to with new tutorial video regarding shear in RCC design. So first we understand what we learn in this shear topic. So basically we learn how this shear apply in our RCC beam. Number 2, what is the shear stress in our RCC beam and what happen due to this shear, that is the effect of RCC beam. Then what is the IS code recommendation? Number 5, how the reinforcement bar is provided due to shear, so that is called as your shear reinforcement, as well as type of shear reinforcement. And after understanding all these things, we will learn how to design, that is the main point, how to design the shear reinforcement, and definitely we will solve the maths. So in this particular manner, I am trying to cover all the shear related topic in RCC. Hope this will help in your preparation time, reduce your preparation time, and that is for your better understanding also. So today I start introduction. How this shear come in the or introduced in the RCC beam, okay, or RCC any kind of structure. So let's assume this is our a simple beam. In practical scenario, all kind of force that is called our what UV, UDL, sometimes UVL, but maximum times this is our UDL, that is uniformly distributed load, okay. But one thing I am telling you, what do you mean by shear? Shear, that means something is 180 to the plane or 0 degree to the plane or parallel to the plane. Yeah, it may be stress, it may be force. If it is stress, that is 180 degree or 0 degree or parallel to the plane. If it is force, then same 180 degree or 0 degree or parallel to the plane of action. So yeah, this is UDL. So if this is UDL, then this is your deflection pattern. And if this is your deflection pattern and this is your bending pattern. So in this whole section, bending moment occur. We know one thing, that is dm by dx equal to v. That is a one formula, dm by dx equal to v, and integration dm equal to v dx plus some constant. That means we knew it from our strength of material chapter, shear force bending moment diagram, rate of change of bending moment is known as shear force, or area under shear is known as bending moment. We know these two statements. So in every section there is a moment will occur. So from this moment changing every section. So in RCC beam, change of moment in every section. From here, shear stress or shear force is introduced. Hope the concept is clear to you. I hope this is clear. If you have any kind of doubt, definitely do comment in comment section. I will definitely get back to you. Okay. So now if you come to the formula section, then shear stress Q, that is equal to V into A y bar divided by I into B. Q equal to your shear stress, V equal to shear force at the section. A is the cross sectional area, I is the moment of inertia, B is your breadth, and y bar equal to Cg. And what is A dot y bar? The first moment of area about neutral axis. So this is first moment of area from neutral axis. That means if you draw a picture, suppose this is your cross section, this is your neutral axis. Suppose you find this section, shear stress of this section. Then what is the value of y? The y should be this. So this is your formula. But mostly when we start to design the shear in beam, then maximum time we follow a particular equation, that is Q equal to 3V by 2BD. Or sometime you see Q equal to 1.5 BD. From here you can say tau equal to 1.5 times tau average. From here you find some MCQ in any kind of exam. Now if I sharing the diagram, then what is your shear diagram? See, this is your cross section of a beam. This is your neutral axis. So your diagram should be like this. Your diagram should be like this. If this is your D, this is your B, then shear force is maximum at neutral axis, that is Q max. So where shear force is maximum, this is neutral axis. This is another your MCQ. That Q max equal to 3 by 2 V by BD. So that is tau max. So from this diagram we can actually write this value. So yeah, this is your beam section and this is your shear stress diagram. Okay, so yeah, this is all about today's video, where I discuss the actual introduction part of shear stress in your RCC section, and as well as I shared the formula of shear stress. Then I draw the diagram. So hope there will be no kind of doubt, but in case if you have any kind of doubt, definitely do comment in the comment section. I will definitely get back to you. And if you find some value from this video, then definitely like and subscribe this channel, like this video, and share the video to your civil engineering friend. Yeah, till then, bye bye, take care, and next video will talk about your shear stress in RCCB. In RCCB. Okay, so yeah, thank you for watching this video.